Okay, so I just want to, okay, my phone is also beside me. In case you want to, you can just chat, Zoom chat, or you can text me, or you can just shout the question that you want me to go through. Okay, huh? So it's assignment 1. This is the first question. Is there anyone that question they want? Question 1 is, I send you the solutions via WhatsApp as well. I send you the solutions via WhatsApp as well. In case maybe you want to mute, in case you want. Which question do you need me to go through? You can WhatsApp me, you can Zoom chat, you can just unmute and shout also can. I hope you all can do. Okay, must do lah. Okay, must do. Just very long ago. Okay. Question 3. Okay, question 3. Okay, there are 2 people who asked for question 3. So I'm going to go through question 3. So help me to submit. I realize quite a lot of you all never submit your topic 2 work. So try to submit. Let me to take a look. I might not mark, but at least I can see that you just look through a working. That's all. Okay. Okay, question 3 is a good question. Yeah, try to look at this. Okay. A and B are acute angles. Okay. Wait, let me check. Question 3. Okay. Okay, very good. A and B are acute angles such that A plus B is equals to 135 degrees. Now, I want to show that tangent AB, tangent A, tangent B minus tangent A minus tangent B is equals to 1. Okay, so if I look at this, right, the fact that they tell me that A plus B is 135, this will also tell me that tangent of A plus B is the same as tangent of 135 degrees. And tangent 135, we can use the idea that, if we take tangent theta is the same, negative of tangent theta is tangent of 180 degree minus theta, right? This is the same as tangent 135 can be the same as negative of tangent 180 minus 135, which is negative tangent 45, and that's negative 1. Okay, that's negative 1. Okay, so then from here, using the addition formula, tangent A plus tangent B equals to 1 minus tangent A, tangent B. So this one is just formula, formula. On the right hand side, I know that this is equals to negative 1. Then after that, I cross multiply. Okay, I cross multiply. So what I do is I cross multiply. So negative 1 can be seen as negative 1 over 1 now. I cross multiply. Left hand side. So those in gray, I will put on the left. Those in blue, I put on the right. You can see that I have tangent A plus tangent B on the left equals to, okay, if I take 1, this will be tangent A, tangent B minus 1. So because I multiply by negative 1, then from here, okay, you can see I'm almost there already. Tangent A, tangent B, you can see I'm almost there already. Okay, so what I'm going to do is I'm going to shift 1 to the left. I'm going to shift tangent A, tangent B to the right. And you can see if I have tangent A, tangent B, subtract tangent A, subtract tangent B, because the 2 of them have shifted to the right. 1 has shifted to the left. And you can see that I've already gotten my part 1. Okay, I've already gotten my part 1. I just need to swap place. If left equals to right, it's the same as right equals to left. So I have tangent A, tangent B, minus tangent A, minus tangent B equals to 1. And therefore, shown. So far, okay? For those who ask, you can give me a indicator whether okay or not. I'll just pause a while in case you need to copy. Yeah, I'll just pause a while in case you need to copy.
Wait, Mr. Tan,
Yeah.
how did you get the equals to negative 1 over 1 for the tan A plus tan B over 1 minus tan A tan B?
Okay, because tangent 135, right, is equals to negative 1. So tangent 135 here is equals to negative 1. I mean, one way is I can use calculator. Another way is I can say that tangent 135 is the same as negative of tangent 180 minus 135, which is negative of tangent 45. And 45 is a special angle. So negative of tangent 45 will be equals to negative 1. So because a plus b is equals to 135, naturally, if I take tangent on both sides, so-called if I add a tangent on the left, I add a tangent on the right, I can also infer that tangent of a plus b is equals to tangent 135, which is equals to negative 1. So far, okay? Can help me to know your progress. So let's say if you give a thumbs up or you just shout, that's it. You just unmute and tell me I cannot. Okay, tell me I can't follow, then I'll go. Then now can on your camera also. Try to on your camera so I can see your expression. Not to check on you, but to see whether you're comfortable or not. Cheryl, are you at home or are you in school? Cheryl, are you drinking Starbucks? On your camera, okay. Okay, can. Okay, so I go to part 2, okay? I go to part 2. Okay, so part 2, now without using a calculator, I want to find the exact value of 67.5. So, okay, if you look at 67.5, now I look at this, then they use the word then. When they say then, it's almost like a hence. It's almost like hence. So I'm also thinking that, so if you are using this, is there any possibility that this and this are connected? Are they connected? Are they linked? So what I'll do is I'll look at 67.5, and it seems like double of this will give me 135, right? Double of this will be 135. So very simply, in the earlier question, we know that if in part 1, we know the following, right? We know that tangent A plus B, if tangent A plus B is equals to negative 1, given A plus B is equals to 135, then part 1 result tell us that tangent A, tangent B minus tangent A minus tangent B is equals to 1. The very simple substitution is you just sub A as 67.5 and B as 67.5. Naturally, you are going to get this, okay, because this is a very nice substitution. They both add up to 135. So all we need to do is we sub A as 135, tangent 67.5, that's my A. Tangent B also, tangent 67.5 minus tangent 67.5 minus tangent 67.5 equals to 1. Okay, so you notice how I've substituted all my A's at 67.5. I've also substituted all my B's at 67.5. The reason is because A plus B is 135. This is from part 1, and I'm making full use of part 1's result. Okay, I'm making full use of part 1's result. So far, okay? Shikai, okay? Shikai, are you there? Can you hear me? Can, okay. So,
yeah.
Can, so far, I'm going all right, okay. If I'm too fast, you let me know. Okay, then from there, because there are so many tangent 67.5, how about if I just let x equals to tangent 67.5 lah? Just a very humble substitution. You can see that this will become x, 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 x. So it becomes something like you end up with x squared minus 2x equals to 1. X squared minus 2x equals to 1. Okay, now solving this equation, you can use completing the square whatsoever. So you get x equals to square root 2 plus 1. Okay, the other answer is negative 2 plus 1, which you will reject. The reason is because x has to be positive. Okay, because you must remember that here 67.5 is in quadrant 1. Therefore, tangent 67.5 has to be positive. All right, so well with that, we solve for exact value of tangent 67.5 and we are done. So tangent 67.5 degrees is equals to square root 2 plus 1. Okay, and we are done with this portion. Sorry, can you all hear me? Can you all hear me?
Yeah.
Sorry, internet, I think internet was bad. Okay. 没关系. Okay. So can you tell me the next question? Question 4, part 3. Question 4, part 3. Question 4, part 3. Question 4 show that L, for part 3, given that exactly uses 310 meters of fencing, find the value of theta. So I believe question 4, part 3, okay. Let me see. Okay, this question, one of the things to take note is, okay, let me check. Am I sharing screen? Oh dear, my internet very bad. Okay. Can you all hear me?
Yes.
Okay. So question 4, part 3. Okay, basically the advanced part of the net. Okay, so in part 1, the answer that you got would be P is equals to 160, Q is equals to 80, and R is equals to 160 as well. Okay, so if I express L in the form of P plus R sine theta plus alpha, I believe part 2 answer, what you will get is for part 2. The answer that you get is 160 plus 80 square root 5 sine of theta plus 1.11. So far, okay? Can so from here, if I look at this portion, okay, then after that, because it's in radian, so I want this exactly to be 310. So in part 3, we want the answer to be exactly 310. So 160 plus 80 square root 5 sine theta plus 1.11 this is equals to 310. So this is how we solve the question. Then after that, 80 square root 5 sine theta plus 1.11 equals to 310 minus 160, which is 150. Then you divide by 80 square root 5 and sine theta 1.11. And from here, you can solve your question already, which is eventually theta will be equals to 1.04. Okay, this is for question 4, part 3, for those who ask. Hope it's okay with you. Is question 4, part 3 okay? Okay, thank you. Okay, then question 5. Okay, question 5, the man was halfway up a 10-meter pole. The observer from the flagpole looked up at the man and the top of the pole. So angles of elevation are alpha and alpha plus beta respectively. Okay, express tangent beta in terms of x. So from here, what I do is, okay, let me see. Give me a second. Let me shift my table outside. Sorry. Give me a while. Okay, so from here, then after that, tangent alpha, tangent beta, what I can say is,
Mr. Tang,
yeah.
your question is different.
Oh, question different. Question 5? Not this one, huh? Which one? It's not this question, is it? Or question 5? It's a different question. Is it a different question? Okay, then let me look at the notes. This one. Okay. H 5 meters high. Okay. So I start from part 1. If I know this is theta plus alpha. Then tangent of theta plus alpha. If I were to use Pythagoras theorem of H prime and green, opposite over adjacent, this is the same as H prime plus H over X. At the same time, what I can do is I can consider this. Let's see if I can change this to tangent A plus tangent B over 1 minus tangent A, tangent B, which is also equals to H prime plus H over X. Now at the same time, tangent alpha, I know if it's the same as H over X. So tangent theta, I'm going to replace tangent alpha as H over X. Then I'll write down 1 minus tangent theta multiplied by H over X is equals to H prime plus H over X. So far, okay? Okay, this is H over X over here is basically done by using the green color triangle. Okay, it's by green color triangle. So now, okay, I multiply by For the left hand side, you notice I'm going to multiply by x over x. Okay, I'm going to multiply by x over x. This is just so that I can simplify my fraction. Otherwise, if I have a fraction in a fraction, it doesn't look so nice. So x to x to this, that gives me x tangent. Sorry. Oh, another way is I can, let me see. I can just cross multiply. I can just cross multiply. So h prime plus h 1 minus tangent theta h over x equals to tangent theta plus h over x times x. Okay. Now for simplicity's sake, I'm going to make it a bit more simpler. I just let y to be tangent theta, so that I don't have to spend so much time writing. Okay, so I'm going to call this y. I'm going to call this y. I'm going to call this y. So this will just be xy plus cancel h. So now what I want to do is to make y the subject. Then this is h prime y 1 minus yh over x. Okay. Then after you simplify, things should be better. Okay, so this will be h prime plus h minus h y of h prime over x plus y h square over x equals to xy plus h. Now remember that we want tangent theta to be the subject. So we want all the y's over here to be the subject. I'm going to bring all my y's to one side. I'm going to bring all the tangent theta to one side. So this and this and this, I'm going to put them together. Okay, I'm going to put them together. So xy plus y h prime over x minus yh square over x. This is equals to h prime plus h. These two can cancel off, so no more. It's just like that. Okay. So this will be h prime. Slowly bring over again. Okay. If I multiply by x on both sides, this will become x squared y. This will become y h prime. This will become y. This is x h prime. Okay, remember we want y to be the subject. So y x squared plus h prime minus h squared is equals to x of h prime. Okay, sorry for that. Okay, so from here, my y is just equals to x h prime over x squared plus h prime minus h squared. So from here, I'm going to replace back my y and call it tangent theta. And you can see I'm done. Okay, yeah. So just a note. Okay, I think this one should be minus, not plus. This one should be minus. Maybe that's why the mistake is there. So I'll just pause about 1 minute at this question for you all to copy. My answer is slightly different from the answer in the solution. If you're okay with this question, just let me know. Maybe give me a thumbs up or something. Then I will go to part 2. Okay, I'll go to part 2. Huh? So part 2, given that alpha is the angle of elevation of the base of the screen from point O, prove that tangent theta is less than cotangent alpha. Okay, so tangent theta is this. Okay, so by right, in this question, they use plus. In this question, they use plus, even though I think there's a mistake in the question. Okay, so there's a x. Okay, first of all, I know x squared plus h squared is more than 0. Okay, so prove that this is tangent alpha. What is tangent alpha? Okay, cotangent alpha is the same as 1 over tangent alpha. And tangent alpha, as we know, is h over x. Okay, so it's like 1 over h over x using Pythagoras theorem, which is x over h. Okay, so at the same time, what's my tangent theta? My tangent theta is supposedly this. Is supposedly this. So I'm going to use the addition for this case. X squared plus h squared plus h prime. So I know that h and h prime, this is positive. This is positive. Because if I have a smaller denominator, I'm actually bigger in value. So this is lesser than this, for sure. Okay, this is lesser than this for sure. Because I know that this is positive, right? So if I have a smaller denominator, definitely I'm bigger in value. Okay, definitely I'm bigger in value. Okay. Okay, so from here, then xh prime. So this, okay, let me see. This is the same as, okay. Another way is I can say this, okay. I can consider that this is the only one that is over h of h prime. Okay, since this is positive, this is positive. Okay, the reason because if you compare here to here, it has a smaller denominator. If it has a smaller denominator, it is bigger in value. It is bigger in value. And if I cancel, you can see that this is equals to x over h, which is cotangent alpha. So this is less than this. Hope this assignment is okay so far. Anything you just Zoom chat me. In case you WhatsApp me, I left my phone in the room. I ran out to the living room because my internet low. Just help me Zoom chat or just shout here. Okay. Sorry. My phone is not with me now. In case you text me, I'm not with my phone now. Okay. Nicholas okay吗？Owen, Wei Xiong. Should I go on? Okay, I slowly go on to part assignment 2. Okay, I think there's no more for assignment 1. So I'm going to go to assignment 2. I'm going to go to assignment 2. Okay. Okay, for assignment 2, is there any question that you want me to go through? Is it okay you Zoom chat me? You just text in the Zoom chat, or you can just shout out. I will copy down.
Can you go through part C?
See, okay. Any more? Question 2. Do I go through question 2 also? I think should lah. I think should lah. Question 2. Okay, question 2 is a good question. Try to do it a few times, maybe like 5,000 times. Okay, tangent normal, all this quite important. Is going to come out. Okay, definitely you will get a question to find tangent, find normal. Okay, so take note of that. Okay, so for question 2, topic 2, question 1C. Now remember that when we differentiate loss of logarithm, we always use we differentiate log. We always use loss of logarithm first. Okay, very, very, very important. Please make sure you write down. Okay, always use loss of logarithm first. Always loss of log first before you differentiate. Otherwise, you're going to take 15 minutes to do the question, whereas other students will take 30 seconds. Okay, so for this, right, you notice that, okay, this is power 3, power 2. So this is the same. 1C is the same as your y. It also can be considered as ln 5 over 8x minus 3 to the power of 2 over 3, which is the same by the power law, is 2/3 of ln 5 over 8x minus 3. So here to here, I'm using the power law of logarithm. Then I bring it down using the quotient law. This is the same as ln 5 minus ln of 8x minus 3. So from here to here, what I use is the quotient law. The quotient law of logarithm. Okay. Now, I have not differentiated yet. Okay, so don't stop here. Okay, this is not a question on log. It's a question on differentiation. So if I differentiate this, it's going to give me 0. If I differentiate this, my y, 2/3 will be left outside. So this is 2/3 of 0 minus, remember when we differentiate ln of fx, this will give us f prime x over fx. So if we consider this as our fx, then f prime will just be 8 over 8x minus 3. Okay, remember this is f prime over fx. F prime over fx. Final answer, you will have 2/3, 2 times 8 over 3 bracket 8x minus 3, which is finally 16 over 3 of 8x minus 3. Okay, differentiation of log will come out. You need to know, please make sure you know, and you know your loss of logarithm. So if you have a logbook for your test, remember, go and memorize the loss of logarithm. You don't need to, like practice the whole topic MA 300 log all over again, but you do need to know how to apply the loss of logarithm to differentiating a log function. Okay, that is very, very important. Very, very, very important. Okay, can So a question. Yes.
Is it supposed to be negative because it was 0 minus 8 over 8x minus 3?
Oh, yes. Sorry, thank you. So minus, then minus. My bad. Thank you. Shikai, okay? Can okay. Yancy, are you okay? Inga, are you okay? Kaden, Amanda, on your camera. Okay. Wei Xiong, okay, ma? Cannot, okay. So just make sure you know how to do this question. Make sure you know how to do this question. Try to do it quite a few times. Okay. Anything that involves loss of logarithm and differentiation together. Now, the equation of a curve is cosine over 5 minus sine x. So this is where you are finding tangent normal, but you are using according to a trigo curve. So find the equation of the tangent to the curve that is parallel to the x-axis at a point where x is between 0 and pi over 2. So if they say that the equation of the tangent is parallel to the x-axis, what does it mean is that, okay, no, if you have is probably you have, example, if you visualize, you probably have a curve. The curve maybe looks something like this. Then the curve, there's a tangent parallel to the x-axis. Sorry, I never draw very well. Again. The tangent looks like that. Parallel to x-axis. So this is the x-axis, and this is your tangent. And there's this point where this point is between 0 and probably pi over 2. This particular x, I don't know what is it, but it's between 0 and pi over 2. So what can you infer is that if they talk about parallel to the x-axis, it will mean that your dy dx is equal to 0 at x1. Okay, at this point, the gradient is 0. And we differentiate the gradient. Remember, I told you that dy dx it basically takes in x for breakfast, lunch, and dinner. So I differentiate. After differentiation, so okay, you call this u, you call this v. Okay, so your u is equal to cos x. Du dx is negative sine. V is 5 minus sine x. dv dx is negative cosine. Now, using the quotient rule, because we see a quotient, your dy dx is u over v, u die first. Okay, so u die first, multiply by v, subtract v die, which is minus cos x, multiply by u over v squared. Okay, so I don't really need to so-called be bothered about how pretty it looks like, but eventually this guy should simplify to, let me see, this is question 2. Just give me a sec, let me pull out the fast answer. The final answer you should get is, okay, negative 5 sine x. Negative 5 sine x over 5 minus sine x squared. So that is the gradient function, and you're supposed to equate to 0. Okay, you're supposed to equate to 0. Okay, so you're supposed to equate to 0. Okay, let me check. Let me double check this part. Okay, I suspect got some issue here. This is negative 5 sine x. Minus is a plus sine square. Minus, this is a plus cosine square. Okay, equals to 5 minus sine x square. So if you are cosine square, I'll be sine square. Together will be 1. So this should be minus 5 sine x plus 1 over 5 minus sine x square. Okay, that's the gradient. That's the gradient. So I know that at this point, at this particular point, this guy is equal to 0. Your dy dx is equal to 0. So from here, if I want this to be 0, the denominator is useless. The denominator can never be 0. Straight away, the implication is that your sine x plus 1 must be equals to 0. Okay, because we only consider the numerator. The denominator not important. I can just throw it away. For a fraction to be 0, only the numerator can be 0. This means that if I simplify, 5 sine x equals to 1. Sine x equals to 1 over 5. And I solve this. The answer I should get is x should be 0.201358. Now, basically, you can just do sine inverse because they are only looking at the first quadrant. I only... Yes?
Isn't it -1?
-1.
When you bring it over?
Oh, -5 sine x. If I bring over, is positive 5 sine x.
Oh, okay.
Cannot. So that means this answer here, this is equal to 0.201358 radian. So far, okay? So with this value, right? With this value, after I know this, right? What do? I only know that I've found the x coordinate of that point, but I need the equation of the tangent. So very simple. You sub x equals to 0.201358 into y equals cosine, sub back into this. Okay, so remember, you know that x now is equal to 0.201358. You sub into y. Okay, so if you have cosine 0.201358 over 5 minus sine of 0.201358. Radian mode is supposed to give you 0.204. Why do I need this y coordinate here? Is because you see, this point here is 0.201358. Your y coordinate is 0.204. It tells you that this horizontal line, the equation is y equals to 0.204. Okay, the equation, the y is equal to 0.204. Okay, so far okay. So it's this horizontal line here. It's this horizontal line. Because the y coordinate can give me the equation of this line, that's fine. That's why I find the equation of the tangent. Is this good for you? Our singer okay, man? You all look like got question to ask. NC, are you okay? Okay, Tasha, okay? So if you're okay, do help me to submit your assignment and practice set online. Okay, so allow me to take a look. I know all the solutions provided, but just submit. Let me take a look. Cannot. Most important is okay. So for tomorrow onwards, tomorrow, what I need to go through with y'all is the R formula question and how to sketch certain graphs. Okay, how to sketch trigo graphs. Okay, from R formula question. This is for tomorrow. So bring your topic one notes tomorrow. Bring your topic ones tomorrow, as well as topic 1 AFL3, as well as your revision package. So far, okay? This is for tomorrow. Okay, help me to bring your topic 1 notes. I need to go through the question 3.5. Basically, I need to go through question 3.5. Help me to bring your AFL3. Okay, today, main highlight is, I told you a few things. Number 1, equation of tangent normal. You need to know how to do. Okay, you must know how to do, how to find equation of tangent, how to find equation of normal. Number 2, when you differentiate log functions, make sure that you know how to use loss of logarithm. Okay, just help me take away these 2 tips. It will help you for your quiz. Okay, can. Okay, that's all for today. Thank you for accommodating. Hope to see you all soon. Bye bye.
Thank you, Mr. Tan.
Thank you.
Thank you.
Thank you, Mr. Tan.
Braden, are you there?
Mr.
Braden?
Tan.
Braden. You can help me call Braden. Wait.
Can. Brandon, Mr. Tan call you. Just come.
Braden, are you there?
Yeah, please. Yeah.
Braden. Your Braden, you can,
It's so unhygienic.
Braden, can you hear me?
Hey, you, I can rejoin. What? Yes, hello.
Can you hear me?
Wait, there's no sound.
Can you hear me?
Yeah, I can hear.
Okay, for your NDP rehearsal, right? You can go for it. For the Python arranging, they might do Zoom lessons and record the lesson for you.
Oh, okay, can.
Can off, just to let you know.
Okay, thank you.
Bye bye.
Bye bye.